that you're starting off with the units place, you got say 55 plus 55. So at this point of time, there is no carry. So 5 and 5 is 0. So actually this is 0 plus 5 plus 5. 0 plus 5 plus 5. So we'll say that this is the C, this is the A, and this is the B. And in fact, what is it? This is the C1, A1, B1. Look at the units place. This is the now. Then now we have a carry, and this carry goes there. So now we have a C2 and an A2 and a B2. Do you all get it? So now that is 5 plus 5 is 10 plus 1 is 11. So 1 and a carry. So this is your S1. This is your S2 and another carry is there. This is your C n plus 1, isn't it? So this is saying n plus 1. So this C n plus 1 carry, this now carries over to the left and you have a this. This is a sum 3 which is given by carry plus A3 equal to 0, B3 equal to 0. Or if this is a 2-bit number, then this is a carry that is to be stored for later on. Is this understandable by you all? Or do you want me to repeat? Okay. So Divya, is it clear? Okay. Very good. So similarly, so just like that, you have this. So you add A1 plus B1, that's the first bit, so 0, the S1. The carry of this is going on to the there. Okay. So just like we had a 5 and a 5, and we had a 0. Then this was a 0, and 1 was carried here. So we had another 5 and a 5. This became a 1, and the 1 was carried here. And these two were zeros, so the sum became 1. So we had 1, 1, 0. We take from here to here this time round, because they have done it the opposite way around. Actually, it should be this way. They have done it this way, but it should be this way rather. So it should be 1. So that sum is 1, 1, 0. Like that. Here also, they're making it. So all the carries are carrying forward to the next adder, next adder, next adder, next adder, next adder. So we have a sum. The 15th sum is there. Now there is a carry of this. Now this is a C16 obviously. Either the C16 will sit down here. So if this is a binary sequence, so this is a binary sequence, the carry will be a 1. So 1 will be sitting on the left. So we have 1 something. That will be our number. Or this will be shifted to a carry register, which will indicate that the number was full and that there was a carry of 1. This is a parallel adder where all the bits are added through separate adders and the carry is got from the previous adder. And the first adder gets a 0 as a carry. Simple. Is that understood by everybody? Oh my God. Is that understood by everybody? Okay, very good. Okay, very good, very good. Explain the last carry bit again. Okay, so explain the last carry bit. So Diva says explain the last carry bit. So basically we have S15. So that like that here we had a 2-digit number, decimal number we are talking about. So there were two of these, 0 and 1, and there was a third one. So the third one sat here. How did we do that? By adding 0 and 0 to the, because we didn't have any more numbers or any more digits to add. So we added that. So that was there. So similarly here also, when you have the 15th sum, so 15-digit number, two 15-digit numbers are being added. So the 15th sum is there, all the bits are now there, but then there is a carry. Let's say that the last one is 1 and 1. So obviously if there is a 1 and 1, there's a 1 and 1 here, or let's say the last one is 1 and 1 and 1. In that case, there will be a carry of, there will be a 1 and a carry of 1. So C16 will be 1. Is that correct? Now in that C16, what are we going to do? So if it's a 16-bit number and there is a place for the C16, it will be sitting absolutely at the left. So the number will start from 1 and then go on like this. On the other hand, if this number is a, now if this number goes on to, now let us say that we do not have place for the 16th bit. In that case, that will go into a separate register called the carry register. which will contain the carry, which will indicate that there was a carry at the 15th sum, but we are unable to process it because the sum, the for the moment, the number of places that we have is 15. It was a 16 bit, so we could not process it. So we are storing it in this carry register. Understand? Okay, that's good. So this is the parallel adder, and you see that a very fast adder, very fast adder. But you can imagine so many adders are necessary for it. It's a very fast adder, but then so many adders are necessary, so it'll be expensive and it'll require more space. Yes, go on.